In this video, we're going to look at working out critical regions of a Poisson distribution, given that we've got a one-tailed test. So let's take an example. An agent or an estate agent has been selling houses at a rate of 9 per month. He believes that the rate of sales will decrease in the next month. Part A, using a 5% level of significance, find the critical region for a one-tailed test of the hypothesis that the rate of sales will decrease from 9 per month. So let's take an approach to the question. So we're going to first define the random variable. So we say let the random variable x represents the number of houses sold in a month. Number of houses sold in a month. Very standard in statistics, in A-level maths or regular A-level maths and further maths A-level, that you define your random variable very clearly. Then we're going to do the following. We're going to see that, we'll say that H0 is lambda equals to 9, but the claim is that there's been a decrease. So that implies that the alternative hypothesis means that lambda must be less than 9. So we say there's a one-tail lower test, as we've stated in previous videos, one-tail lower test, and we can say that alpha is 0.05. So we've set up our hypothesis test there. So now we're going to do what we did previously by setting up our model. Oh, I should have written my model down. So let me see if I can move this bit down a little bit. Yeah, so must have the model before that. So x follows the Poisson of 9. That's fine. So now that looks good. So now we're going to say the probability, and because it's a lower tail, we say the probability that x is less than or equal to C1 is strictly less than 0.05. That's the lower tail of the distribution. Just a reminder, I'll just draw it to you again. I'm not going to draw it in the next example, I'm just going to draw it here. That what we're trying to do is work out the lower tail probability. So we shade this here, all of that. Call this as C1, and we can describe that as the probability that x is less than or equal to C1, and this area is 0.05. So that's visually what's happening here. So we can use tables, as I alluded to in previous videos, or I didn't really allude to it, I state it very clearly. So from tables, we're going to look at 9, and we're going to find the value strictly less than 0.05. So go to lambda mean 9, the two values we want, get a highlighter, we want this value, we want that value. Let's write them down in our notepad. So from tables, we can say the following, that the probability that x is less than or equal to 3 is 0.0212. It's just good practice to always write the one that's greater than it, so you're convincing the examiner the value chosen is true. So x is less than or equal to 4, and that value is 0.0550. So we can say since 0.0212 is strictly less than 0.05, we can say therefore C1 is 3. So the critical region required is that x is less than or equal to 3. So the probability of x being less than or equal to 3 is going to be 0.0212. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. I'm going to define a random variable. So let x be the random variable. That, or representing the number of accidents at the crossroads. In a 12-month period. So we can define our model. So we can say x follows. Well, if we go back to the question, it states that it's a rate of 0.5 per month. We've got 12 months, so you've got to do n times p in this case. So in our case, 12 times 0.5, so lambda is 6. We get that x follows the Poisson distribution of lambda being 6. Now let's set up our hypothesis. So we're going to say the following here, that we have as follows. H0, lambda remains at 6. H1 is a decrease, so lambda is less than 6. So it's a one-tailed lower test. And we're going to say that alpha is 0.05, the significance level of the test. So, as we said the last time, the probability that x is less than C1 is strictly less than 0.05. So I drew the diagram in the example so you know what that looks like. I'll draw it for you again here, just in case for clarity you want that. So I know it's extraneous, but it's good for you to visualize what's happening. So this is 0.05 here. This is the critical value. And we can describe that as the probability that x is less than or equal to C1. So from tables, and it has to be strictly less than 0.05. So from tables, and we're going to get our Poisson tables now, looking at lambda being 6. So we go to our Poisson tables, go to lambda being 6, and get our highlighter now. So we're going to scroll down to 6 here, and you want to find the value where we're greater than 0.05 and we're going to be lower than 0.05. Just write it down in our notebook. So writing that down in our exercise books, we have the following. We have probability that x is less than or equal to 1 is going to be 0.0174, and we're going to have the probability that x is less than or equal to 2. Improve the clarity of my handwriting there. Is 0.0620. We can infer, therefore, so we can say therefore, the critical region is, right, is a bit clearer. X is less than or equal to 1. And we're done.